Hi everyone, this is the 160th video of the ACT Math Practice Problem series, and here we have an interesting problem from the concept of remainder theorem. As I always recommend, before seeing the solution, you can give it a try yourself, and after that of course you want to match with my solution. So let's get started. Here the question says, if x to the power 75 is divided by x squared minus 1, the remainder will be which of the following 5 options? This is clearly a problem from the remainder theorem. So what is the remainder theorem? Well, the general form of the remainder theorem is something like this. The original function can be written as the product of quotient and the divisor plus the remainder, right? So in our example, f of x is actually x to the power 75 is equal to, let's assume that we get some sort of a quotient, right? It would be definitely a function of x. So let's say this is q of x, that's the quotient, times what is the divisor in this case? Well, in this case the divisor is x squared minus 1. So let me write it like that, x squared minus 1, and plus remainder. Now what would be the remainder when this function is divided by a quadratic expression? Well, the remainder will definitely be a linear function, because here the highest power of x in the divisor is 2, so the remainder can have highest power of x as 1. So that means it will be a linear function. Maybe something like, let's say, a times x plus b. That is the most important point actually in this problem, that the highest power of x in the remainder is 1 less than the highest power of x in the divisor. Alright, now from here let's try to solve it. So we have two unknowns that we have to figure out, a and b, and q of x is also an unknown, but somehow we will use some suitable values of x so that q of x disappears from our equation, right? So now can we write it like this, x to the power 75 is equal to q of x times, let's factor x squared minus 1, and that would be x plus 1 times x minus 1, because you know that a squared minus b squared equals a plus b times a minus b, and then our remainder is here a times x plus b. Now let's try to use two suitable values of x so that q of x will disappear, and we will also get two equations to find the values of a and b. Now one suitable value I can clearly see is a positive 1 and the other one is negative 1. So let's first try with the positive 1 and see what happens. So if we say x equals positive 1, if we use that value, then what do we get? Well, then our equation will look like this. 1 to the power 75 is equal to q of 1 times 1 plus 1 times 1 minus 1 plus a times 1 plus b. And from here what do we get? Well, from here this is 1, obviously left hand side will be 1 to the power 75, that's 1, is equal to, right here you see this term is actually 0, this is actually 0, that means this first term, the entire first term becomes 0. Alright, that's nice. So this is 0 plus then a times 1, that is a plus b. And from here we can clearly see that a plus b is equal to 1, and that is our equation number 1. Let's try to create another equation, and this time I'm going to use another value of x, that is x equals negative 1. So let's try that. If we use x equals negative 1, then let's see what happens. There again we can say negative 1 to the power 75 is equal to q of negative 1 times negative 1 plus 1 times negative 1 minus 1 plus a times negative 1 plus b. And from here we can say, well, then this is negative 1 obviously, because negative 1 raised to an odd power, that will become negative 1, is equal to this other term again becomes 0 right here. This factor is 0. So that means this entire first term is becoming 0. So then we can say this is 0 plus negative a plus b. And from here what can we say? Clearly we can see that negative a plus b is equal to negative 1, and that is our equation number 2. And from these two equations we have to find the value of a and b. So let's quickly do that. So what are the equations that we got so far? We have a plus b equals 1, and negative a plus b is equal to negative 1. So then let's add these two equations, and if we add them, what do we get? Well, positive a, negative a, they will cancel out each other. So we'll have 2 times b is equal to 0, and from here we can say b is equal to 0. Now let's try to find the value of a. So now now let's subtract the second equation from the first equation. So what is our first equation? Well, our first equation is a plus b is equal to 1, and now we are going to subtract the second equation. So the negative a will become positive a, and then the positive b will become negative b, and the negative 1 will become positive 1. We are simply doing a subtraction, so this is the algebraic sum we have to do. So then positive b, negative b will cancel each other, and we are going to be left with 2 times a is equal to 2, and from here clearly a is equal to 1. Alright, so we have found the value of a and b. So what is our remainder then? Well, our remainder is actually a times x plus b. So let's try to calculate that. So our remainder would be a times x plus b, and now let's use the value of a and b. A is actually 1, so that is 1 times x plus b is 0, so that is actually x. So our remainder is actually x, and that is our answer. And if we look at the answer options, we have x under option H, so option H would be the correct option. I hope everything made sense. Thank you for watching. See you in the next video.